Jai Hind students, welcome to my YouTube channel. Students, time can be your best friend and your worst enemy as well, depending on whether you use it or waste it, right? So students, a dream doesn't become reality through magic. No one has got a magic wand, isn't it? So in order to fulfill your dream, it will take sweat, determination, and obviously hard work. Your ability to discipline yourself, to set clear goals, and then to work towards them every day will do more to guarantee your success than any other single factor. So with that students, let's begin today's session. Today we are going to start a very important and very interesting topic, and the topic is friction. Yes, the topic is friction. In this lecture, we will be discussing or aiming to cover these topics. First, I will introduce the concept of friction. Then, we will obviously discuss the cause of friction. There is old view and there is modern view. We will be discussing both the old view as well as the modern view so as to discuss the cause of friction. Then, we will be discussing types of friction, static friction, limiting static friction, kinetic friction, and then also we will prove that static friction is a self-adjusting force. Anyways, these are the topics which we are going to cover in this particular lecture. And students, please watch this video till the very end. I've included some very interesting animations in this video just to make the teaching learning process more enthralling and enjoyable for you, right? So I will introduce this topic of friction with the help of this short animation. So let's first watch this animation, right? Let us consider a ball to be moving on a flat ground and there is no external force acting on it. Will the ball eventually come to a halt? Yes, it will. Students, have you ever wondered why? Let's take another example. Say that you are skating on an ice rink and your friend is skating on road. Whose movement do you think will be smoother? Definitely yours. Let's take some other example. When you hold a bottle in your hand, why it isn't just slip through and fall? Sometimes when you are walking around in a mall, do you remember seeing a caution sign to warn you about the floor being wet? What explains all this? The answer is friction. The reason behind the ball coming to halt is the force of friction. The reason why skating on an ice rink is easier because force of friction is lesser on an ice rink than on the road surface. The bottle doesn't slip through because the force of friction between your hand and the bottle doesn't allow it to do so. And in the last case, if the floor is wet, the friction offered by the floor reduces and you might slip and eventually fall. So, what is this friction we are talking about? It's quite easy to understand its concept. Friction is nothing but an opposing force. It is the force exerted by a surface when an object moves or tends to move across it. In the first case, when we consider the ball to be moving on a flat ground, then the force of friction always tends to act in a direction opposite to which the ball tends to move. And in the second case, the force of friction get greatly reduced when the person is skating on an ice rink. The ice rink offers less friction, while on the other hand, the road surface offers high friction. In case of bottle, the weight of the bottle acts downward. By holding the bottle with our hand, the surface of the hand exerts a friction force in the upward direction, which balances the weight of the bottle. And in the last case, the soapy water reduces the friction on the floor. So students, in the animation, we have seen various examples, right? Like the motion of a football, and after covering some displacement or distance, the football eventually comes to rest, indicating that a retarding force must be acting, which is opposing its motion, isn't it? Then the case of skating on an ice rink. So on an ice rink, the skating is quite effortless, isn't it? And seamless as compared to the skating on road. So it suggests that friction does depend upon the nature of the two surfaces in contact as well, right? Then the holding of the bottle. So in that case, it is only due to the friction offered by the hand, right? By the surface of the hand with the bottle surface, which prevents the bottle from slipping down. Then we have also discussed how wet floor, in the case of wet floor, one tends to slip and eventually fall. That's due to the reduction in the friction. So basically students, 2-3 points can be easily concluded. One is, force of friction is always of opposing nature, isn't it? That is, it always tends to act in a direction opposite to which the body tends to move, isn't it? Second is, force of friction does depend upon the nature of the surfaces in contact. Now soapy floor, it reduces the friction. Then friction on an ice skating rink is comparatively much less as compared to the friction offered by the road surface, isn't it? So, generalizing, we can safely conclude that friction is that opposing force which get established between the two surfaces in contact when a body slides or rolls or tends to do so over the surface of another body. So again I repeat students, friction is the opposing force that is set up between the surfaces in contact when one body slides or rolls or tends to do so on the surface of some other body. Clear students? So students, before we proceed further, we need to make familiar with the cause of friction. That is an important concept. What causes friction? There are basically two views. One is the old view and the other one is the modern view. Again, before we discuss these old view and modern view regarding the cause of friction, I would like you to watch this small animation. It is worthwhile to know about the origin of friction. Students, the surfaces of bodies which ordinarily look smooth are found to possess irregularities in the form of projections and depressions when observed under a microscope. When a body, say A, is placed on another body B, the lower body, then the projections in the surfaces of the two bodies get interlocked. When body A is given a small push, then the projections in the surface of body A exert sidewise force on the projections in the surface of body B. Now, as per Newton's third law of motion, the projections in the surface of body B give an equal and opposite reaction, and it is this reaction which opposes the motion of body A and is termed as friction. As the body A remains at rest, it follows that force of friction has become equal to the applied force. As the push is continuously increased, a stage comes when the interlocks get broken. Then the body A starts sliding, and the force of friction still acts between the two surfaces due to the interlocking that occurs between some other projections and depressions. However, once the interlocks get broken, the effort required to break the fresh interlocks is less than that needed earlier. Students, let us revise the cause of friction, right? Let's start with the old view. What we have discussed in this short animation is that the surfaces which otherwise seems to be very smooth, but when observed under microscope, these surfaces will be found to contain several irregularities in the form of elevations, projections and depressions. So students, when a body is placed, suppose body A is placed on the surface of some other body B, then what happens is the elevations of body A and the elevations and depressions of body B get interlocked. They get interlocked, isn't it? They will get interlocked. So as a result, what happens is, if now I intend to push or slide this body A over body B, then what happens is, body A will exert sideways force to the projections of body B, and as per action reaction, body B will exert an equal and opposite force to body A, which will act in a direction opposite to that in which the body A tends to move, isn't it? So this reaction exerted by the elevations of body A on body B, that is known as actually friction, which is the opposing force. So this is the applied force. In this direction, the force of friction will act. So force of friction, as we discussed, is always of opposing nature. It always tends to act in a direction opposite to which the body tends to move, right? Here I must tell you, force of friction can even exist when a body is at rest. I'll tell you how. Suppose a body is placed on a horizontal floor. If a small push is given, then the body might not move, it might remain at rest only. So it means that the applied force is being balanced by that opposing force, and that opposing force which is preventing the body from changing its state from rest to motion, that is known as the force of static friction, right? If you still apply some more force on that body, the body again might not move at all. So it suggests that the force of friction also increases in magnitude with the increase of the applied force. Anyway, this we will discuss with the help of a diagram later on in this particular session, right? Coming back to this, students, so what causes friction as per the old view? It is due to the interlocking of the elevations and depressions of the two surfaces in contact. So students, old view, it is friction is caused due to the interlocking of projections and depressions. Projections and depressions. So, as per the old view, the friction is caused due to the interlocking of projections and depressions of the two surfaces in contact. So, as per old view students, as the surfaces are made smoother and smoother, so as a result, what should happen? The friction should keep on decreasing, and this is correct up to a certain level. So as the surfaces are made smooth, the force of friction also get reduced. But students, once the surfaces are considered to be extra smooth, then it is found to offer very large friction. So this point couldn't be explained with the help of old view, right? So for that, in order to explain this concept, that why extra smooth surfaces offer very large friction, modern view was developed, right? So from this we can safely conclude that in addition to the interlocking of elevations and depressions of the two surfaces in contact, there must be some other reason as well which causes the friction. And students, that reason was explained in modern view, and that is the existence of atomic and molecular forces of attraction, right? So this is as per old view, and as per modern view, as per students modern view, the friction, the cause of friction, it was explained on the basis of atomic and molecular attractions between the two surfaces at the point of actual contact. So what happens is, we are aware of intermolecular forces, isn't it? The force that exists between the atoms or molecules are known as intermolecular forces. They are short range forces. They are effective only for very small distances, and they are of attractive nature, right? And there are two types of intermolecular forces: adhesive force and cohesive intermolecular forces. Adhesive intermolecular forces are the intermolecular forces between the molecules or the atoms of different surfaces or different substances, while cohesive intermolecular forces are the intermolecular forces of attraction between the atoms or molecules of the same substance. So here obviously at the point of contact, the atoms or the molecules of one surface will strongly interact with the atoms or molecules of the other surface. So there is a molecular bond. So if I intend to push or slide body A relative to body B, then I have to do some work or effort is required to be done against that molecular bond, isn't it? Against that molecular bond of attraction, and that opposition offered by the atomic or the molecular interaction, that is the cause of friction. So when we consider extra smooth surfaces to be in contact with each other, then there will be large number of points of contact. So there will be more molecules of the two surfaces strongly interacting with each other. So in order to break those molecular bonds, stronger effort, more effort will be required. So that tells us why friction increases for extra smooth surfaces. So students, always remember, if you are asked what is the cause of friction, then you need to answer both through old view as well as through modern view. Let me again tell you once again, right? The friction is caused first due to the irregularities in the form of projections, elevations or depressions. So whenever two such surfaces are made in contact with each other, then the interlocking of these elevations and depressions takes place. So if we intend to slide a body over the surface of some other body, then due to this interlocking, the motion of the body is hindered, and that gives rise to friction. And second is, students, in order to justify why extra smooth surfaces offer more friction, the modern view was developed, and friction, the cause of friction was explained on the basis of intermolecular attractions, right? Intermolecular interactions between the atoms or molecules. So the adhesive force of attraction between the atoms of the two surfaces at the actual point of contact, that may be considered to be the cause of friction. So in order to make a body to slide or to roll or to move on the surface of some other body, those molecular bonds needs to be broken first. So there arises the concept of friction. So I hope students we have understood this concept. Is it? Students, let us consider a wooden block A to be placed on a tabletop which can be considered to be body B, right? Initially the wooden block is at rest. Suppose a pulling force or a force is applied and the wooden block doesn't move. Then some more effort is applied on that body so as to make it move. But if still the body doesn't move, it means that the opposing force, its magnitude has also increased with the increase in the applied force, isn't it? And again students, if the applied force is increased still further and even now the body still remains at rest, it means that the force of friction has again increased its value so as to be always equal to the applied force, so that the body always remains under the influence of balanced forces. So as a result, the body remains at rest only. So till the body remains at rest, the force of friction that comes into existence between the two surfaces in contact is known as static friction. And students, here you must remember the very fact that in the absence of any pulling force or the applied force, static friction will be zero. So static friction will be present or it will come into existence only when some force is applied on the body and the body doesn't move. Understood, students? So one more conclusion we can draw from this observation is that the magnitude of static friction increases with the increase in the magnitude of the applied or the pulling force. So static friction is directly proportional to the pulling force or the applied force till the body remains at rest. So whatever we have discussed, let us represent it diagrammatically, right? This is the block, students, block A, which is placed on tabletop B. Let's consider first case. Suppose no force is applied, so here the body is at rest. So here the applied force is 0. So the static force of friction is also 0. Right, students? So static force of friction exists only when some force is applied on the body. In the absence of any external force, the static friction is 0. Right? Now suppose a small pulling force is applied, say F dash, and if the body remains at rest, so it clearly suggests that there must be an opposing or retarding force which must be opposing this pulling force so as to make the body remain at rest. So what it means is that the wooden block must be under the influence of balanced force. So here the magnitude of the static friction must be equal to that of the applied force. So the body remains at rest only. Right? So with the increase in the strength of the applied force, the force of friction also comes into existence and its magnitude also increases. Now students, in case C, suppose the applied force is further increased, say to F double dash, right? Still suppose the body remains at rest. So it means that the body is again under the influence of balanced forces. So initially it was at rest, now also it is at rest. So it means that now the magnitude of the static force of friction has also increased so as to be exactly equal and opposite to that of the pulling force. So the net force acting on the body is 0. So that is the reason why the body still remains at rest only. So what is the conclusion basically? First is, in the absence of any applied force, the static force of friction is 0. Second is, as long as the body remains at rest, with the increase in the applied force, the force of static friction also increases. That is, if Fs represents the static friction, then till the body remains at rest, static friction is directly proportional to the pulling or the applied force. So if you plot a graph between static force of friction and the applied force, it should be a straight line passing through the origin, right? This is the first observation which we can safely conclude, right? Okay, now what happens is, students, let us assume in this case, on applying an applied force which is greater than the previous one, F triple dash is greater than F double dash. That is, the applied or the pulling force is gradually increased. So suppose in this situation, the body is on the verge of motion. Body is on the verge of motion. That is, the body begins to move, just begins to move. So here, the force of static friction is maximum, and that maximum static frictional force is known as limiting static friction. So students, how do you define FLS? It is the limiting static friction. It is defined as the maximum static friction that can exist between the two surfaces in contact, before which the body actually starts moving. So the maximum static frictional force is known as limiting static friction. Right, students? So this gives the measure of the frictional force, and it will be equal to the applied force. Actually, the pulling force, it actually gives the measure of the force of friction, right? Now students, suppose the applied force is further increased, right? It further increased. Now observe the length of the arrows indicating the applied force and the frictional force. The length is gradually increased, length of the arrows indicating the increase in the magnitude of the applied force, right? Here suppose the body starts moving. If this applied force is greater than that of the force of friction, this is the maximum value. So here, once the body starts moving, it will start moving because it will be greater than that of the frictional force, right? So in this case, the body will be under the influence of unbalanced force, so it will get accelerated along the direction of the net force. So once the body starts moving, then the force of friction that comes into play between the two surfaces in contact is known as kinetic friction. And students, the kinetic friction is slightly less than that of the limiting static friction. So it should be represented by an arrow which is less than the arrow representing the limiting static friction, right? So here I have represented FLS as the limiting static friction, and Fk, it is the kinetic friction. Now again, let's revise these terms, right? Static friction, as long as the body remains at rest, even under the influence of some pulling or applied force, then the force of friction that comes into play between the two surfaces in contact is known as the static friction. This is the first point. Second is, as long as the body remains at rest, the static friction increases with the increase in the pulling force or the applied force. So static friction is directly proportional to the applied force, right? Third, limiting static friction. It is the maximum static friction which can exist between the two surfaces in contact just before the body starts moving, right? So that is limiting static friction. Once the body under the influence of unbalanced forces starts moving, then also force of friction comes into play. That force of friction is known as kinetic friction. And students, remember, kinetic friction is more or less independent of the velocity of the moving body. It depends upon the relative motion, right? Also, one more important point is kinetic friction is always less than that of the limiting static friction. This is a very, very important point, right? I'll explain it. Now students, look, consider a heavy, huge block to be placed on a horizontal floor, right? In order to change its state from rest to motion, tremendous effort will be required. A great effort will be required. But once that heavy block comes in motion, then lesser effort will be required to maintain its motion. So that's the reason why kinetic friction is always less than that of the limiting static friction. I'll convince you again by molecular theory, right? What happens is the effort which is required to break the fresh interlocks is less than the effort required to break the interlocks initially when the body just begins to move. Understood, students? So, as the interlocks are broken, the body starts moving and new interlocking takes place between the elevations and the depressions. So it is found that it is much easier or less effort is required to break these new interlocks as compared to the earlier interlocks when the body is just on the verge of motion. So that is the reason why kinetic friction is always less than that of the limiting static friction. Right, students? Okay, now let us depict all these observations in the form of a graph. So we'll plot a graph between the frictional force and the applied force. Initially, as you can see, as long as the body remains at rest, the force of friction initially in the absence of applied force is 0. So here applied force is 0, the force of friction will also be 0. Right? So the graph should start from the origin. Now, if the applied force is 1 Newton, then the static friction will also be 1 Newton because the body must be under the influence of balanced forces because it is remaining at rest. Now, if the applied force is increased to 2 Newton, then the static force of friction, its magnitude will be also increased to 2 Newton because the body again remains at rest only. So what you find is, initially just before the body actually starts moving, the static friction, its magnitude increases with the increase in the applied force proportionately. So they are linearly dependent. So graph between these two would be a straight line passing through the origin, right? So the graph would be somewhat like this. This is the graph between static friction and the applied force. It is a straight line. Static friction is directly proportional to the applied force, right? Here's to it. When the body is just on the verge of motion, the body just starts moving, then the static friction is maximum. That is known as limiting static friction, right? Which is indicated by diagram D. So here you need to represent a hump like this. So this, suppose this is A, this maximum value, this is the maximum value of the static friction. This is known as limiting static friction. It is the maximum value of the static friction just before the body actually starts moving, right? And as I told you, students, when the body starts moving, then also force of friction comes into play. But that force of friction becomes kinetic or dynamic friction, isn't it? And kinetic friction, as we discussed just now, is less than that of the limiting static friction. And kinetic friction being independent of the motion of the body, therefore it would be a straight line parallel to the horizontal axis. So this represents the kinetic friction, which is more or less constant and is slightly less than the limiting static friction, isn't it? So this is a graph showing the variation between the force of friction and the applied force. So this is a very important graph, right? So we have discussed static friction, limiting static friction, kinetic friction, and then the graphical study between the frictional force and the applied force. So I hope students you have understood each and every concept and you have enjoyed this session thoroughly, right? So that's it for this particular lecture. We will meet in the next lecture. Till then, do take very good care of yourself and thank you.